Hello and welcome grade 4s to this Worksheet Cloud grade 4 maths lesson all about two-dimensional shapes. I'm Mr. T, or maths teacher for today. In this lesson about shapes at Worksheet Cloud, we like to make learning fun, and in an effort to do that, we've created a brand new rewards hub where you can earn rewards while you learn. Things like Nomu hot chocolate to make those study breaks that much sweeter, or perhaps even a PlayStation 5 for after you've finished your maths work, a reward to look forward to. But for now, let's get back to the maths. So, 2D shapes. Our goals for today is to know the shape families or the groups of them. We kind of just have to learn which ones are which and how we identify them and how we name them. Hopefully we'll have some ways in which we can classify them, and then also particularly to know the difference between what a regular shape is and what an irregular shape is. There's some vocabulary connected with shapes, which I think is probably important to just go through before we move on to looking at the different families. First of all, the word polygon. Always, whenever I read the word polygon, I think, the parrot's gone, polygon. But it has nothing to do with parrots. It means a closed shape. In other words, the lines that make up the shape join together to form a chain so that you can't have a gap where you can escape. So it's a closed shape made up of straight lines, that's important, straight lines, and vertices. Vertices means where two lines join. Important that thing about straight lines. So if it has curved lines, it can't be a polygon. Remember that. Okay, vertex. Vertex, and in brackets vertices. Vertex is one spot where two lines meet, and when we talk about more than one, like the corners of a square or something like that, then we talk about the vertices of a square. A straight line is basically the shortest distance between any 2 points. If you think about it, if you take any longer, then your line won't be straight anymore. Okay, so straight line. And a curved line joins those 2 points, but it isn't the shortest way. So at some point, it's just going slightly in a bent way. Now, don't think with two straight lines, because then we're talking about two straight lines, and that's 3 points, not two. So if you've got 2 points over here and you're not using the straightest distance, then it will naturally be a curve. Or it could be a curve, but it'll be a curve if it's not the shortest distance. Okay, on to our first family, triangles. A triangle is a polygon that has 3 sides and 3 corners. That's pretty much it. So remember the definition of a polygon: must have straight sides, right, and must be a closed figure. That is not a triangle. It's actually not even a polygon because it's not a closed figure. So this doesn't even fit the definition of a polygon. So even though it has 3 lines, it's not a triangle. Neither is that. Why is that not a triangle? Some people like to call it a curvy triangle. Other people call it a helmet. It does actually have a fun name, a Relu triangle or something like that, but it's not a polygon and it's not a triangle because the sides are not straight, so it doesn't meet the definition of a polygon. Triangles are then given more specific names depending on some of their characteristics. So we have a right angle triangle, or right triangles. Some teachers call it right triangles. I like to call it right angle triangle. It has one angle of 90 degrees. Okay, I'm just making a note here because I want to show you why it can't possibly have two. Okay, All right, so it's got one angle that's 90 degrees. Please don't get caught out thinking that it always needs to be the bottom left-hand corner. It can be the top corner, it can be any corner. As long as one of the corners is 90 degrees, then it's a right angle triangle or a right triangle. The next one is the isosceles triangle. For some reason, I can never spell isosceles right. That is right because I spell checked it, but I don't know. For some reason, that S and the C and the S, I just never get it right. I always have to check. But an isosceles triangle has two straight sides, it has two sides that are the same and two angles that are the same. All right, so you can see down here are three examples of isosceles triangles. So in this triangle, these two sides are the same length, and these two angles are the same. All right, so I'm assuming you have a knowledge of what angles are, which you should. These particular ones are acute angles, but this is an isosceles triangle, and you'll notice that the two angles that are the same are always at the base. So they're at the side where they are at the corners where the two sides that are the same meet the third side. So in this triangle, these two are the ones that are the same, and where they meet the other side, those two angles are equal. We call this the base side, even though it's not necessarily at the bottom. In this one, we have two straight sides. They're all straight. Two sides that are equal, and our base angles, with the angle that they make where they meet the third side, are the same. So those are isosceles triangles. So we've got right angle triangles and isosceles triangles. We've got some more triangle families or some more triangles. We have scalene triangles, and in a scalene triangle, basically everything's different. Nothing's the same. Each side is a different length and each angle is different. So here are some examples. All of the sides, that's not the same as that, it's not the same as that. That angle and that angle and that angle are all different. These look similar, but they're not the same. Same with this. We have three different angles that are all different and three different length sides that are all different. And this one too, all the sides are different, all the angles are different. These look close to the same length, but they are not the same length. The next one is a very special one, and there's only one way that this triangle can be. It's called the equilateral triangle or equilateral triangle, and you can see equi kind of looks like equal, and basically all the sides are equal and all the angles are equal. Not only are all the angles equal, they're actually always a very specific size, and when you learn more about the angles of a triangle and what they add up to, that'll come into play, but each of those angles is exactly 60 degrees every single time you have an equilateral triangle. So an equilateral triangle obviously can be turned in any direction, but as long as all the sides are the same and all the angles are the same, it's an equilateral triangle. Now, just to give us a little bit more of a headache when it comes to naming these, we combine these names to give us better descriptions. All right, so I'm going to jump across to the whiteboard so I can give you a little bit more of an idea of what I mean by that. Okay, so let me go across to the whiteboard. Okay, first things first, I've got to switch off my ruler, and I think I said I was going to show you, I was going to show you why you cannot have, why you can't have two, I just want to double check that this is going to show up on the whiteboard when I draw. Yes, it is. Okay. All right. Why you can't have two 90-degree angles in a right angle triangle. So I need my ruler on actually. All right, so I'm going to draw a 90-degree angle. Remember that a 90-degree angle is like the corner of a page. Not going to go any further into angles. Now, if I wanted to draw another right angle, it would either have to be over here at the top or it would have to be over here at the bottom. Either one of those, if I drew it there, I don't get a closed figure, so it's not a polygon. And if I draw it here, I don't get a closed figure, and so it's not a polygon. And that's why you can only ever have one right angle in a triangle. It's simply not possible to have more. Okay, so we got two names here. These are now combining the names. We've got a right-angled isosceles triangle, and we've got a right-angled scalene. All right, I'm going to draw my right-angled isosceles. No, not my right-angled isosceles. I am going to draw a right-angled isosceles, but let's go like that. All right, so those two sides are the same length. This corner is 90 degrees. I can tell that they're the same length. I hope you can see the little squares in the background that are showing me that this is 10 little squares long and this is 10 long, or two of the big ones. All right, and finally I'm going to join those two together, and that's going to give me my triangle with these two sides being equal, making it an isosceles triangle, and these two angles being the same as part of the rules for an isosceles triangle. Okay, so we have a right-angled isosceles triangle. On the other side, I'm going to draw a right-angled scalene triangle. Right, so I'm going to draw it like that. I'm going to put in a right angle. Oops, nope. I've got to do it in 2 steps. I'm going to join that up. So I can see that each of my sides is a different length. This one is not the same as this one, is not the same as this one. Those little lines, by the way, tell us when things are equal. So when I was drawing this over here, because there's one line through each of those, it shows that those are equal. On the other side where I've said there's one, it says that anything else with one in it is equal, but there's nothing else. Anything else with 2 lines across it is equal, but there's nothing else. Anything with 3 lines across is equal, there's nothing else. All right, so that's some terminology that you're not using yet, or some diagrammatic representations. Now, you might also have a teacher who talks about things like an obtuse triangle or an acute triangle. An acute triangle would simply be a triangle which has all acute angles. All right, so when we're talking about acute angles, we're looking at angles that are less than 90 degrees. So that's all acute. I'd say that actually looks like a little bit like an acute isosceles. I think those look like they're the same length. They might not actually be, but let's assume that they are. So then that's an acute isosceles triangle. So you see what I mean about combining the names so that we can give it a better description of what it is. Okay, and then you've also got what teachers will term an obtuse triangle. And an obtuse triangle is then a triangle that has an angle, only one angle, of more than 90 degrees. And again, in this situation, we can only have one that's more than 90, and this is an obtuse scalene because none of the things are the same, and it's an obtuse triangle. So that's what I'm talking about when we expand our understanding of what it looks like by giving it a longer name. That will come with time. I think the most important thing for now, let's go back to our slides. The most important thing for now is to be able to name these 4 types of triangles. So the right angle triangles, the isosceles triangles, the scalene triangles, and the king of the triangles, the equilateral triangle. It's like the most perfect of the triangles. And now we get on to, just before we do, just a thing. Tri means 3. So a triangle has 3 sides. A triangular series in cricket, for example, is between 3 teams. A tricycle has 3 wheels. So tri means 3. So whenever you see the word tri, you'll know that there's something to do with 3 in there. When we're talking about 2, which obviously you can't have a 2-sided shape because that's just a line, or you can't make an enclosed shape with 2 lines, is what I'm saying. But bi is the word that means 2. So when you've got a bicycle, it's got 2 wheels. That's what we're talking about. Okay, and next we get on to the quadrilaterals. And quad means four. So quadrilaterals are four-sided polygons. Whew, there are quite a few polygons. Quite a few quadrilaterals. I think just before we delve into these, we should probably have a slightly early no moo hot chocolate break. So cheers to you. Nope, I'm not done. I'm having another one. Let's be honest, studying sucks. But here at Worksheet Cloud, we make it suck way less. In Worksheet Cloud, you can earn avatars, sidekicks, collectible coins, and then level up all while studying. Plus, we've just added our most exciting feature to date, the brand new Worksheet Cloud Rewards Hub. With Worksheet Cloud Rewards Hub, you can earn epic rewards and unlock entry tickets to win real giveaway prizes, including a Sony PlayStation 5, some yummy Nomu hot chocolate, and some fresh Worksheet Cloud merch. The more questions you answer, the more points you earn, and the more rewards you unlock. Worksheet Cloud makes your studying easier with video lessons, practice exams, practice questions, and study notes. In other words, we're your go-to place for all your studying. Ask your parents to sign you up at worksheetcloud.com today. Right, back to maths. My pencil, it seems to have switched off. All right, quadrilaterals, four-sided shapes. You might also have seen the word quad in quad bikes, which have four wheels. A quadrangular series would be between four teams. A quadruped would be an animal with four legs. So all of those are a thing. Quad means four. So quadrilateral are four-sided polygons. All right. Once again, we have different names for quadrilaterals depending on what their special characteristics are. If we just have four sides and there's no other information given, that's all I've got, then I can only call it a quadrilateral. And I say, that is a quadrilateral. End of story. However, if we have one of these where we have two sides that are parallel, so one pair of parallel sides, so this side and this side are parallel, we call that a trapezium. The Americans call it a trapezoid, but we call it a trapezium. So it's got one pair of parallel sides. If you're not certain about what parallel means, it means that they go on side by side like a pair of railway tracks, and they never get closer together and they never get further apart. They travel next to each other but will never ever meet. So this has one pair of lines like that. Okay, actually the word trapezoid, we have a muscle that is a sort of kind of shaped like this. It's up here at the top of our backs. It's the trapezoid muscle. All right, but that's not important. I think you might learn about that in grade 7 biology or maybe high school. I'm not sure. Then we have a kite, which looks like a kite. And that's why it's called a kite. And the thing about a kite is it's got two pairs of adjacent sides equal. Now, adjacent is a very fancy word for just saying that those are next to each other. So these two are the same length, and then these two are the same length. Now, there's a lot of other information about the insides of each of these shapes, but that's not part of the grade 4 syllabus, and so I'm not going to go into that just yet. Things about the diagonals and the angles and all sorts of things. You can see that they have labeled on this that the opposite angles, these two and these two, are equal. These two are different, however, so it's where the two different length sides meet, those are the same. Next up, we have a parallelogram. Parallelogram. If you ever get stuck trying to spell parallel, just remember that the two L's are parallel. So sometimes people try and spell it with two R's instead of two L's. I remember there's two L's because they are like the parallel lines. So this has two pairs or two sets. So 2 and 2 is 4. So the red two are parallel and the blue two are parallel. And there is stuff about angles, but again, not going to go into that. All right, so parallelogram has two pairs of parallel sides. The opposite sides are parallel. Oopsie. Okay, so obviously I somehow paired the background color with rectangle, but doesn't matter. We're there now. The rectangle is kind of like a special parallelogram. We've taken the parallelogram and we've taken it from being slanted and we've put it upright. So the only difference between these two, in fact, the other thing about just before the rectangle, the other thing about the parallelogram is that the opposite sides are also equal length. So this is the same length as this, and this one is the same length as this. So with a rectangle, as you should know from working with rectangles in area, these two sides are parallel. Well, you wouldn't know they're parallel, but you know that they're equal. They are also parallel. These two sides are equal and parallel, and all of the corners are 90 degrees. So really the only big difference between these two is that with a rectangle, the corners are 90, like the corner of a page. Okay, the rhombus, often called a diamond. Its better name is a rhombus. You should really remember the word rhombus. And this one has two pairs of parallel sides, so the opposite sides are again parallel, like what we've looked at in the last two shapes. And then all the sides are equal. So another way of thinking is it's a square that's been slightly squashed, because squares have all the sides the same, and so do rhombuses. The difference is that the rhombus has been squished a little or pushed over a little bit, so its angles are not all 90 degrees. And finally, we have the king of the quads, the special of the special, and there's so much information about the insides and the diagonals and blah, blah, blah. Not part of your syllabus this year. But a square has two pairs of opposite sides parallel, all the sides are the same length, and all the corners are 90 degrees. So you can see, in a way, these two are related. The only difference is that in this one, we have long sides and short sides, and in this one, we have all the same length sides. Otherwise, they're the same. And these two are related because this one has all the same sides and they're parallel, and this one, the only difference is it now has the 90-degree corners. That is the quadrilaterals. You will do quite a lot of work when it comes to working with quadrilaterals as you go through primary school. Pentagons. Pentagons have 5 sides. That's the rule. Now we get 2 types of pentagon. Any polygon that has 5 sides is a pentagon, even if it looks a little odd. If you want to name it properly, then we would say this is an irregular pentagon, because it's not what we normally think of when we say the pentagon. That's this one, the regular pentagon. So in a regular pentagon, it's a polygon with 5 sides, and all of the sides are the same, and all of the angles are the same. With an irregular polygon, we just have 5 sides. So it's a polygon with 5 sides, but they don't have to be the same, and they don't have to have the angles the same. Some teachers might also want to call this a concave irregular polygon, because we've got a side that bends inwards instead of outwards. But I think most people would be fine just calling that an irregular polygon. Hexagons. Right, a hexagon is any 6-sided shape. And once again, we have 2. We have the irregular one and the regular one. Regular being that I've just tilted on its side, but all of the sides are the same, all of the angles are the same. It's a regular pentagon. And the other one, an irregular one. It just doesn't have all of them being the same and all the angles being the same. You might have seen this in nature. That is some honeycomb from a beehive, a naturally occurring hexagon. There it is. Which brings us to the curved shapes. You might have a teacher who throws in some other ones. There's one that looks a bit like a donut, and there's others that look a bit like a lens. People use all funny names. These are the most important ones. So the top left is a circle. You'll learn lots more about circles, calculating the area of circles and the perimeter of circles, which is called the circumference later on, but that's not part of this year's syllabus. The next one that looks a little bit like an egg, I don't want to be drawn into an argument about this. Some people will call it an oval, and other people will call it an ellipse. I'm not going to go into any more details. Mostly it's just used interchangeably. You can call it either an oval or an ellipse. And then the bottom one, which is a half circle, is called a semicircle. All right, let's jump across to the whiteboard and see how well you have been paying attention. All right, moving down here. Okay, we're just going to do it for a few minutes where I'm going to draw a shape and see if you can name it. So let's start off by simply going for what kind of shape is it? Is it a pentagon, a hexagon, a triangle, a quadrilateral? So we're not going to go into the details, just the simple bit on the outside. So see if you can name, let's just check I'm in the right place. Yeah. What is that shape? I'm sure you got it. Well done. It is a triangle. What is that shape? So when you're faced with a question, what is that shape? My suggestion is start off by counting the sides. And if I count the sides there, I get 5, which means that this is a 5-sided polygon called a pentagon. What's that one? Count the sides. 6 sides, hexagon. That one, 4 sides, quadrilateral. Okay, now you're going to have to excuse my not so brilliant drawing. What shape is that? If you guessed semicircle, then you'd be correct. If you guessed circle, you'd be correct. That's what I was going for. If you guessed oval, I probably couldn't mark you wrong because it's fairly close. But I would draw an ellipse or an oval more like that. Okay, we've gone through the shapes. Now let's get a little bit more specific. So I'm going to draw a few triangles and I'm going to ask you to see if you can name them. First of all, let's go for their simple names. So we're just looking for those simple ones we looked at. So we've got an equilateral triangle, we've got the isosceles triangle, we've got the right angle triangle and the scalene. All right, so I'm going to draw one of each of them, and then after that we'll move on to looking for their more advanced names. Let's get my ruler out. Oh no, I can't draw it like that. Oh, I can't draw it at that angle. Let's try it. Let's start that one again. What kind of triangle is that? That is a right angle triangle because we have a right angle in one of the corners. What kind of triangle is that? That is an isosceles triangle because we have 2 sides that are the same length and one that is different. And we've got the 2 base angles that are the same. What kind of triangle is that? If you guessed a scalene triangle, you would be correct. Now the hardest one for me to draw, because with the ruler I'm limited to drawing on the corners and it's a little bit harder to draw the exact one I want. Let's see if I can get this right. Oh, it's actually not quite right. That would probably be that is an isosceles triangle, though I was going for the equilateral triangle. Let's see if it'll work with the next one. Yeah, there we go. There's an equilateral triangle. Okay, so I hope that you're on track with those. We're going to move a little bit further down the page, and this time we're looking for their advanced names. So perhaps you will be able to name this one. That would be a right-angled isosceles triangle. And we know it's right angled because we can see the right angle, and we know it's an isosceles triangle because two of the sides are the same. So it's a right angled isosceles. What about that one? Well, start off with right angles. So we always start off with the part. No, we don't. Ignore that comment. That is a right-angled scalene triangle because all the sides and angles are different, but one of those angles is 90 degrees. Okay, so let's see if we can get another one. How about that one? I doubt you'll have to be asked, or doubt you'll be asked one of these in a test, but that is an obtuse scalene. Right, and last one for now of this type. That one. That would be an acute scalene because all the angles are acute and none of the sides are the same and none of the angles are the same. All right. It takes practice. The more you look at it, the easier it becomes. Let's glance at a few of the quadrilaterals. So we're just going to do one of each and then we're going to stop. Then we're going to wrap up. So let's start off with see if you can name that one. While you're thinking about it, I'm going to change colors because I like to do each of the colors or each section in a different color. All right, if you guessed it and you guessed correctly, you would have guessed trapezium. We have one pair of sides that's parallel. Okay, how about this one here? All right, I think most people get this one super easy. This is a kite. Those two sides are the same. Those two sides are the same. So the two pairs of sides that are next to each other are the same. It's a kite. Next up, we have this one. This one is a parallelogram. These two sides are the same length, and those two sides are the same length. And in fact, so that's the symbol that shows they're the same length. And to say that they're parallel, we use these little arrows. So that says that those two lines are parallel, and that says that those two lines are parallel. In fact, I should also have a pair on the first set like that to show that they're parallel. Okay, just a couple to go. Oh, my ruler is not on. What is that one? I'm sure you all got it. It's a square. All the sides are the same. All the angles are 90. We've got parallel lines. If I'm going to put in all my notifications, I should say all the sides are the same length. Those two are parallel to each other. These two are parallel to each other. So the reason why I put the same line in each of these is because I'm saying that each of these lines is the same, and the reason I've got ones on this one is to show that these two are parallel, and twos on this one show these two are parallel. If I had done it like this, it's not actually possible, because it would be saying that this line and this line and this line and this line are all parallel. And if I was to draw all of those lines parallel, that's what I'd get. All right, so we must actually have a different number there. You don't need to know the symbols yet. It's just out of habit that I do it. All right, we've got 2 shapes to go. Let's pretend all of those are exactly the same length. That is a rhombus. All the sides are equal, and we have opposite sides parallel. And our final shape, come on, is a rectangle. We've got opposite sides that are the same length, opposite sides that are parallel, and all the corners are 90 degrees. I should have put that into my square as well. All right. All it takes is practice. The more you do it, the easier it is to remember. It's like when you first arrived at your class this year, you might not have known everyone's names, but by now you know everyone in the class's names. The longer you work with something, the easier it is to remember. And that's what it's all about, is to just practice and remember these things as you go. With that in mind, when you are done with the video, click the link in the description below, which will download your worksheet so that you can practice what it is that we've been going through this lesson. And don't forget to get your parents to sign you up for worksheetcloud.com so that you are eligible for those rewards like hot chocolate for your study breaks and maybe even the PlayStation 5 to look forward to when you finish doing your maths every day. Have a great afternoon, grade 4s.